So now this video discusses about what we call as a de-Broglie equation. So what is a de-Broglie equation? We call it as a de-Broglie equation. So what is the de-Broglie equation? Let's say we have a typical atomic structure. Let's say this is a typical atomic structure. Let's say that is the case. Let me have this. And it contains protons and the neutrons at the center. That is the nucleus. Let's say that is the case. And outside the nucleus contains the energy levels. Let's say this is energy level 1. And let's say this is the energy level, let's say energy level 2. And let's say this is, let's say, energy level 3, and so forth. So we understand that the electrons can be able to move from one energy level to the another energy level. Let's say electron is to move from energy level 1, let's say, to energy level 3. Let's say that is the case. And in all cases, there is an emission of the particles in form of the waves. And alongside that one, there is energy being released. Now, according to the Planck's quantum theory, the energy is given as hv, where this is the Planck's constant, and v is said to be the frequency of the wave. And in that case, the frequency of the wave is also being given as the speed of light divided by the wavelength, in that way. Now, if we consider the particles being emitted, let's say, of having the mass given as m, and also if we consider the speed in which the particle is moving, according to the de-Broglie equation, we can be able to have the wavelength of that particular, the wavelength of the emitted radiations. So now, according to the de-Broglie equation, wavelength, if we consider the mass of the released particle and also the speed it is moving, then the wavelength will be given as the Planck's constant divided by the mass of the particle times its velocity. This is what we call as the de-Broglie equation, and that is being used to have the wavelength if we consider the mass of the emitted particle and the speed in which it is moving with. And this is what we call as the Planck's constant. So this is what we call as the de-Broglie equation, and that is considering the mass of the emitted a particle and the speed in which it is moving with. So that's how you have to get it. And now let's say this is the question. Calculate the wavelength of hydrogen atom of mass. We have the mass which is given as 1.674 times 10 to the power negative 27, and the mass has to be in kgs, and moving at a speed of, that is the speed which is being symbolized as u, that is 7.00 times 10 to the power positive 2 centimeters per second. By the way, this represents power 2, and we should have meters not as cent, so we should have to eliminate the prefix cent. So therefore we'll have it as 7.00 times 10 to the power positive 2. What is the value of cent? It's 10 to the power negative 2 meter per second. So with the calculator, you'll be able to express what is that, and it will be typically being given in meters per second. So that will be given as the speed. And in order to have the wavelength, we use what we call as the de-Broglie equation, which is the Planck's constant divided by the mass of the particle and times the speed in which it is moving with. So you'll be able to have the wavelength there. Now let's say this is a question. We have been given the mass of a particle which is given as 9.1094 times 10 to the power, and that should be negative 31 kgs. By the way, here should be negative 31 kgs. And we have the speed which is given as 68 meters per second, which to have the wavelength. Now use the principle of the de Broglie's equation, which is mass times the speed. You'll be able to have that. So that's how you start to understand about the principles behind de Broglie's equation. You should have to understand about the de Broglie's equation. Thank you.